So our objective was to find the common denominator by ordering fractions. So children will be using manipulatives, and I'll be listening out for those children discussing the lowest common multiple, and this will be shown through the number rods becoming equal to one another as they move on. So for prior learning, we looked at a cold task using the assessment booklets that they use, and I would identify where to start for this journey. And in this case, I needed to return to the Year 5 handbook due to the COVID school closures and work from there. So in the lesson, the children were able to successfully identify and order fractions. Those that do need further support will have a same-day intervention with me and work on identifying the common denominator for just 2 fractions. Those confident will go on to work from the pupil book to deepen their understanding. Our learning objective today is to find the common denominator of fractions with different denominators. So we're going to start by looking at our Numicon on the board. So what fractions have we got? Somebody tell me, Livia?
1/3.
Be careful. What is this?
1/4.
1/4. What would we say? What would we call that?
A quarter.
A quarter. And then we've also got, Livia?
2/3.
2/5. And what I want you to do is, with the Numicon or the Cuisenaires, I would like you to find equivalent fractions. So I've just been through it with Hayden and Peter over there. As far as using the number rods, I would have my 1 and my 4. I'm going to rotate that round. Here we go. 5. What would I add next? What could I do next to see if I can get that, if I'm finding an equivalent? Jensen?
You could add another 4 on and another 1 on.
Okay, so if I do that, rotate that around. And I can just put it above, that's fine. So now what would be my fraction now if this was all part of 1 there? What would my fraction now be, Bradley?
2/8.
2/8. Does that make sense? So you're looking for an equivalent fraction showing it with Numicon. So don't write it in your book just yet. I want everybody, for those 2 fractions, so 1/4 and 2/5, to show me a set of equivalent fractions using the number rods. Off you go. Just keep going with both fractions. Keep going. So now what's the fraction? 3/12. So keep going and then do it with the other ones as well. So then you've got 5ths to do that with as well. Okay? Just keep going with both and then you might spot something. So I'm listening out for something really important that you might notice. So work with both fractions, show me equivalents, and then I'm listening for something that might be really useful. Good. Remember you're doing 1/4 at a time. So 1/4 and again 1/4. Okay. What's the fraction now? 3/12. So if I was to do it again. How many is that? How many is that right? So how many have you got on the bottom? So the denominator is 12. How many have you got on the top? So what's the fraction? Yeah. And then if I was to do it again? What's that number? 16. Yeah. And then you can do one more. What have you got? Do one more. Okay. Show me one. How many have you got? It's got 5/20. Now can you do it with 2/5? So find the equivalent to 2/5. Do it underneath for me. Has anybody noticed anything?
Yes.
What have we noticed? Jensen?
When you put the numbers together and you count them up, if your number is not in the 4 or 5 times tables, then you straight away know that you've done something wrong. So you know when you need to correct it.
Okay, so what knowledge are you using there? Is it knowledge of Jensen?
Times tables.
Times tables. What specifically? Could that be factors, multiples? What sort of knowledge are you having to use to help you with that? Come on, Jensen.
Common multiples?
You're finding common multiples. So, that's what I was looking for. So if on your table you have found where it matches up, and the boys here have got it, the denominators are now the same. Okay? So what is your denominator for both of your fractions?
20.
20. So it's 20 is the common multiple of both 4 and 5. Is the first common multiple. Yeah? We agree on that? First common multiple. What about the numerator? So what's the numerator now for if you have shown those now, what would those fractions be written that you have where they both have the same denominator? So can you write those down in your book? Write those down in your book. So once they are the same denominators, what would the numerator be? So you might want to just write those in. And write in your book what the new fractions are for me. Jensen kindly started us off with finding the common denominator. So we've all agreed now that the common denominator for both of those fractions should be 20. Now we need to look at how we got there. Okay? So looking at the fractions, what did we have to do to the quarter, the 1 over 4, to get it to be 20ths? What did we have to do to the fifths to get it to 20th? How could you use the Cuisinart rods to help you with that? How could you use the Cuisinart rods to help you with that? How might you do that? How might you do that? If I was to look at them, how did I get to 20? How did I get 4 to 20? How did I get 4 to 20? Just have a quick chat with the person next to you. How did you get 4 to 20? What did you do to see that the denominator should be 20? Pretty simple, and that's why it's so you have to do it 1, 2, 3, 4, 5 times. 5 lots of 4 gets you to 20. So if we do fifths, what would you do?
And then you just
Yeah. So we're going to do that on the board in a second. Okay, right. Who has their thoughts about that then? So how do we get our 1/4? We've all agreed that the first it should be something over 20, and our 2/5 should be something over 20. So what did we do to get them to that point? So how did we just come up with 20? We noticed it would become a multiple of both, therefore that's what we know then becomes the common denominator, but how do we get there? Jensen?
When you multiply 4 by 5, you get to 20, which is the lowest common multiple, so that could be both of their denominators. And because you multiply 4 times 5, you need to multiply the numerator, which is 1 by 5, which would turn into 5/20.
So 5 over 20. Okay, and we can check that because we've got our 4s here. So we've got 1, 2, 3, 4, 5. So it's 5 times 4. And we've got our 1 5 times. So 1, 2, 3, 4, 5. So we can check it using our Cuisinart rods as well. Okay, so if we apply that same sort of strategy that Jensen's used for the quarters and apply that to the fifths, somebody else give me that knowledge. So use the same thing that Jensen's just done with the quarters to use for fifths. I want somebody on this side of the room to come up with that. So if I'm doing fifths, what do I need to do to my fifths to get to 20th? Grace?
Times it by 4.
Times it by 4. And Grace, what did Jensen say that because we did the denominator by 4,
We have to do the numerator.
by 4 as well. So what does that become, Grace?
Okay.
So which fraction is larger?
2/5.
2/5. Yeah, so we can write them down like this. Okay, so very simply we've ordered 2 fractions there. Does that make sense?
Yeah.
Yeah, we've ordered 2 fractions. So what we need to have a go at now together is this one. Okay, you can work as a pair, and I'm going to come around and check how you get on. So in the same way that we've done it here, I want to see it in the same sort of layout. Using air rods, and then next to the calculations, you're going to show me what you did to get to the denominator, and then show me what you did for the numerator as well. Okay, off you go. Have a go with your partner for these two fractions here. We're going to find the lowest common multiple. The lowest common multiple is 3 and 5. And if you're not sure, you're not confident, you can do it with a numerator. Okay? So 2/3 push 3. And where's your starting one for the 3/5? 3/5. 5. Okay? So now, keep going until the denominators are the same. Go until the denominators are the same. And when they're equal, these are equivalent fractions, but it also means that the denominator will be the same. You can get 15, so check. Let's check. Let's check. So you should be laying out 2/3 and 3/5, and we're looking for the lowest common multiple. So why don't we pause on this one and do 2/3 and see if we can get an equivalent. Have a look. Right, show me you've got the lowest common multiple. That's right, now check with him. So 2/3, and keep going until they and do it for the 3/5 as well. So showing him, yeah? So you're right with the lowest common multiple, but show me in the increasing errors. If it's a more difficult set of fractions, you might need to use this. Okay, so what you might be looking at is something that we did in our Numicon unit a couple of weeks ago, which is finding the common multiple. But what sort of multiple are we looking for? We're not just looking for any common multiple. What one is going to make it easier for us first, Jack? The lowest common multiple. Have you identified the lowest common multiple for the set of fractions that are on the board here? Have you found the lowest common multiple? Hands up if you think you have. Okay, that's every pair's got their hand up. So, what is the lowest common multiple, Hayden? 15. So what we want to do now is we want to make sure that for our fractions that we've got here, 2/3 will have the denominator of 15, and 3/5 will also have the denominator of 15. Using what we have discussed before with Jensen and Grace, where we were using our Cuisinart rods, what is the calculation that we're going to do to get our 2/3 to have a denominator of 15? What is the calculation we do? What did we have to do? Livia?
How much is 50? So it will be 3 times 5, which is 15.
3 times 5, which is 15.
And then the
Numerator,
3
yeah.
times 5 is 10.
10. So
10, 15.
10 over 15. So what do we do for this one? What do we do for this one? Jack? To get from 5 as our denominator to 15, what do we have to do?
Times the 5 by 3.
The 5 by 3, and because we've done that to our denominator, we must
Do it to the numerator.
do that to the numerator, so what does that become, Jack?
15.
Something over 15. 3 times 3, Jack. 9 over 15. And actually, they're very close, aren't they? Very close. So which is the larger fraction? What symbol will I put in between these two? What symbol would I put? Which way around would I do it? Where does that become? You can come up and do it. Tall enough, I think. Just about. What would you put in there? So which one is the larger fraction? Have a go. And we can discuss if we agree. So 2/3 is 10 over 15 and 3/5 is 9 over 15. Which? Okay. Do we agree with Grace?
Yes.
Yes, we agree with Grace. Good. Okay. So I'm going to now put a selection of more fractions on the board. You're going to follow the same strategy, but there's more than 2 fractions. There might be 3, 4, or even 5 of them, and you are trying to find a common denominator of all 5 of those fractions to then order them in the same way that you've kind of done here. Does that make sense?
Yes.
Excellent. So that's what we're going to do. Can you now tell me what these fractions are? So we've laid them out in increasing error odds. Can you tell me what the fractions are on the board? What is it representing? Holly.
3/5.
So the first one, 3/5. Somebody give me another one and tell me which one they're doing. Peter.
The second one is 7/10.
The second one is 7/10. What's the third one, Jensen?
5/8.
5/8. And the fourth one, Hayden?
The fourth one, 16/20.
16/20. And the last one, Livia?
3/4.
3/4. How else might we say that?
3/4.
3/4, thank you. Okay, so your task now with your partner is to find a common denominator for all of those fractions. Once you've found a common denominator for all of those fractions, you are then going to order them from largest to smallest. So you're ordering them from largest to smallest. Now some of you might have already thought, actually, I already know what the common denominator is. I would still like you, however, to prove that theory, prove what you are saying using decreasing error odds. So I want it represented using the number odds as well. Everybody understand their task? So you're working with your partner to find a common denominator for all of those fractions there. Off you go. Off you go. So you should see the decreasing error odds being used. Go.
Okay.
Okay. Right, so let's take the first one for example. And 3/5. Okay. Now, what would be a good strategy, do you think, for do we do loads of 3/5, or do we do? How would you go about it? Do you think we just do loads of 3/5, or do we maybe do 1 3/5, 1 7/10? How do you think best? Why might that be easier to do one of each?
If you keep doing one, then if you do the next one and it's not the same, you have to do like even more.
Yeah, you might do too many of one, because actually the common denominator might actually be quite small, but you might have extended it too far and you've wasted a lot of time. So if you do one at a time, you might find that one a bit more. Alright, so give that a go. Okay, so you should be doing the same. So start with 3/5. What's the next fraction that you need to work with? 7/10, so you get one lot of 7/10 out. That's it, nice, good. You have to do one of each and then it's easier to line up each one, isn't it? Okay? So you'll go to your next set, or when you do the 20ths. The next one that you do is join in the end. Okay, what needs to go there then? 10. So what is this fraction currently? What's this fraction currently? What's your denominator? 40. What's your numerator? 32. So it's 32 over 40. So you could use your whiteboard pen, keep track of it. So you could write on the table 32 over 40 for this one so far. Okay? So pop it on the end. If you need to add it to it later, you can. So 32 over 40. Yep. So now continue that with this. I wonder if 40 might be a common denominator of all of those. Have a go. Okay. Is that number? I'm sure.
Yes.
How will I find an equivalent if they're all a squash? 9 times. Okay, if everybody just pauses for a second. If you're all close enough so that you can see, so if you can just look towards Peter and Hayden, what they're doing is they've laid out one of each fraction first. So they've laid out one of each fraction first, and then from that point they're going to add one set at a time. And the reason they've done that is so that they can find when each one becomes an equivalent. Yeah? Ready? So you can find when each one becomes an equivalent. So they're not doing loads and loads of one. They can do one of each and continue to build it up over time. So they're going to do another one of the 3/5. Then they're going to go to 7/10 and do another set of 7/10. Because in that way, you're going to work out more quickly and more efficiently when when the fractions line up with a common denominator. Yeah? So what you can see here is a good way of laying that out. You can see there's a good example over there as well with Toby and Livia. So keep working on that, and I'll come around and make sure that everybody's working on the right sort of thing. But also, Peter has drawn on the table with his whiteboard pen just to say what fraction he's got so far. Might be useful, just so you can keep track of that and you don't have to retain so much information. So you said it's 40, so actually you think it's 40. Why don't you see if you can make one straight away?
Which is 40. The common denominator is 40. No, 30. No, yes, the common denominator is 40.
Yeah.
Is it smallest to largest?
Largest to smallest. But if you can you write them back in their original form? So yes, you've got them all over the common denominator. I'm not saying what it is because other people are still working it out. But once you have the common denominator, you need to then order them, but back in their original form. Yeah? Good? It's looking like it's going well now. So keep that going. So right next to it now, have you found a common denominator? Okay, well, that's because that's the next part. Focus on getting the common denominator first. What do you think it's going to be? I think it's going to be 40. So now you're just trying this one to see if that does. Do you know whether 3/4 goes into 40? Does 4 go into 40 equally?
Yes.
Yeah. So you know that that is a common multiple. You just need to show me that now with the Numicon. Yeah? Okay, so everybody has laid out their Numicon on their tables with the common denominator now found. So somebody tell me, what is the common denominator of all of those fractions? Hayden?
40.
40. So what we're looking for now is that all of these fractions will have a denominator of 40. Does everybody agree that that is the common denominator?
Yes.
Yes? Good. Okay. So now, what do we have to do to find the numerator for each of those fractions? I'm going to something like that so we've got some space. So what do we now have to do to find the numerator for each of those fractions? Livia?
You have to multiply it by how much it took to get to 40.
So we have to multiply the numerator the same number of times that we multiplied our denominator by to get to 40. So let's take the first example, 3/5. How many times, how many 5s or 5ths do you have laid out on your tables? Livia?
8.
You have 8. So 8 times 5 is 40. Do we agree?
Yes.
Yes. So what do we then need to do to the numerator, Hugo?
Times that by 8.
Times that by 8. So 3 times 8 is
24.
24. So we have 24 over 40. For the second one, we've got to 40 as our common denominator of all of them. So 7/10. What does that become, Peter? What does 7/10 become now that it's a denominator of 40? What's the numerator? What's the calculation, Peter? 7 times... What is 7 times 4?
7 times 4 is 30.
Is
40.
it? Somebody help Peter out. So 7 times 4 is what, Bradley?
28.
28. Okay, so now we know that actually 7/10 is more than 3/5. So we've already got one set sorted. So let's move on to 5/8. So what did I do with my 8 here to get a denominator of 40? What did I have to do to the 8? And I can do that by counting up how many 8s I've got. So 1, 2, 3, 4, 5. Yeah? And actually it's similar to this one here. Yeah? So 8 times 5 is 40, so therefore I have to do it to my numerator. Do the same. So Jack, what does it become if I'm multiplying that by 5?
25.
25. Very close, but again, it's making it really easy for us to order those fractions. Next one. 16 over 20. So what did I have to do to get my denominator from 20 to 40? What did I have to do to that? Hayden, how did I get my denominator from 20 to 40?
Times it by 2.
Times it by 2. So what do I need to do to the numerator?
Times it by 2.
Times it by 2. So what is 16 times 2, Livia?
32.
32. And 3/4. Now I might already know that because it's a fraction that you would normally do a bit lower down in the school. But 3/4, what does that become over 40? How did you get 4 to 40? You multiplied it by, Peter? 4 to 40? 10. Therefore you need to do that to your numerator. Peter? 30. Good. Okay. So now you've got your fractions, you can start to order them. So we're doing largest to smallest. So what is the largest fraction of all of those? The largest fraction. Hayden?
32 over 40.
32 over 40. So I can write it down with my denominator over 40 first. What's next? I'm going to tick it off as I go. What's next? Holly? What's next?
It is 7 10. Right,
3/4, but we're doing it over our denominator of 40 at the moment, so we're going to do it that way. Off, what's next? Bradley?
7 tenths.
Yeah, or 28 over 40. The next one, Jensen?
5/8.
5/8, so 25 over 40. And then the final one, Ethan?
3/5.
3/5, so it's 24 over 40. Now, most questions would ask you to put them back in their original simplified way, because they're all equivalent of their original. Okay, so this one is 16 over 20. This one is 3/4. The next one is 7/10. The next one is
5/8.
5/8.
3/5.
And the next one is
3/5.
3/5. So now you've been given a question where you've been asked to order these 5 fractions from largest to smallest. If you were to do them without changing the denominator, it'd be quite challenging. But because we found a common denominator, we're now able to order that set of 5 fractions here. We've got them at the bottom there. Okay? So what I'm going to give you a chance to do now, before lunch, is an exit ticket, which is a set of 4 fractions where you're finding a common denominator. So this is one of the Numicon assessment cards that you would do. So if you glue that in your book and then have a go at answering that one, you can use the Numicon. You can, if you know a common denominator already, because you know the lowest common multiple, then have a go at that one for me, please. Okay? So keep going. We're just going to keep going for the last few minutes and then we'll stop. Okay, so keep going. Glue into your book, have a go. If you can find the common denominator for all of those. You don't need those ones now, we've done the one on the board. Yeah, use the Numicon if you wish. Absolutely. If you already know the common denominator, then you can just follow the same sort of strategy, and actually you would then be doing it abstract. Yeah, so this is the concrete. Victoria will be drawing the images of the grease and air rods, but actually you can do this now abstract. So you've used the Numicon and you're showing me now in abstract form. Rather than this stuff. So, what's the common denominator? Okay, good. So now, yeah, and then reorder them. Okay? Right, what's the common denominator for all of those? what can we do? So we know those things. Does 12 go into 30?